Hello everybody, welcome into another lesson. So today we are going to start the Systems of Equations unit. Well, what is a system of equations? It's when you have two or more equations that have the same variables. So right here you have the first equation, y equals 6x. Then you have x plus y equals 28. Well, let's talk about graphically for a minute. These represent two different equations of a line. If you were to graph them, to solve a system of equations, what you're trying to ultimately figure out is where do these two lines intersect. That's exactly what you'll get. Your answer will be an x and y coordinate. It'll be an ordered pair will be your answer. So you can solve systems of equations graphically just by simply drawing the two lines and then seeing where they intersect, but here's the problem with that. Unless you draw your graph and coordinates or the amount of spacing just right, you could get skewed results. The only real way to do it by graphing, honestly, is from a textbook, or if you have graphing paper, which seems harder to come by nowadays to find graphing paper. That's pretty much the only way you can guarantee getting accurate results with the graphing method. That's why I'm not going to spend a lot of time on that, because you can get skewed results. But we are going to do some algebraic methods for the next few lessons. And today's is called the substitution method. It's probably the easiest one of them. The substitution method allows us, whenever we have two equations with the same variables, we can substitute something in for x or y. Well, here you have y equals 6x, then you have x plus y equals 28. Well, y equals 6x, what you can do is take that y equals 6x, you could substitute that into the second equation. So you could substitute from the first equation into the second equation. So how that's going to work is you'll have your x plus your y, okay? Your y equals 6x, you could just put that 6x in right for where y goes, set that equal to 28. Now, we have an equation of one variable. X plus 6x we know is 7x, which equals 28, and then x would equal 4. So what we have now done is obtained the x coordinate of the point of intersection. We want to obtain the y coordinate. So once you're done finding your x coordinate, stick that x equals 4 into the first equation. You could also stick it into the second equation. You'll find it makes no difference. It doesn't make a difference which equation you stick that x value 4 into. For me, I think it's a lot easier to stick it into y equals 6x. So now we'll take y equals that 6 times 4. So that means y equals 24. So you got x equals 4, y equals 24. You end up with the ordered pair 4, 24. And so that's the ordered pair you would get to represent where these two lines intersect, is at 424. If you want to check your work, stick the x value into each equation and you should get the y value of 24 out. It doesn't matter which equation you stick it into, you should get the same y value every time. So the ordered pair you should get to solve this system of equations would be 424. And I do got more examples. Alright, what is the next system? Let's see, we got y equals 2x, then we have 5x minus y, equals 30. Okay. So you have the next system of equations having y equals 2x and then 5x minus y equals 30. Again, we're only dealing with the substitution method today. So we know what we can do now is take that y equals 2x, we could stick that into the second equation. So you'll have your 5x minus your value of y, which was 2x, y equals 2x, so you get 5x minus 2x equals 30. Well, 5x minus 2x, that's 3x, equals 30. That means x would equal 10. So the x-coordinate of where the lines intersect is at 10. Now you want to find your y-coordinate. All you need to do is take your x-coordinate, stick it into one of these equations. I don't know about you, I'm going to go for y equals 2x. So you take y equals 2 times that x value of 10, which means y equals 20. So in the end, you get the ordered pair 10, 20. So these two lines would intersect at the ordered pair 10, 20. And if you're unsure, stick the x-coordinate into at least one of those equations. You should get the y-coordinate of 20 out of it. And yeah, that's all there is to it. You'll see why substitution method's the easiest, but it's not the only method. Sometimes substitution method's not the most ideal for some systems of equations, and in the coming lessons we'll see why that is. Okay, sometimes you don't have just x and y, you'll have a equals 3b. So you got a equals 3b to start with. Then you have a minus b equals 12. So once again, we got two equations, a system of equations, a equals 3b and a minus b equals 12. Well, good news is here they give you a equals 3b, so we could take that and substitute into the second equation. Our a equals 3b, so we'll just do 3b minus b equals 12. Well, 3b minus b is 2b. That would equal 12, which means b equals 6. So we have the b coordinate of the point of intersection being 6. Now we need to solve for the a coordinate. Well, take your b being 6, put it into one of these equations. I'm going to go with a equals 3b. So a equals 3 times 6, which means a equals 18. So you have the a coordinate being 18, the b coordinate being 6. Now, when you list coordinates, they need to go in alphabetical order because a comes before b. So a is 18, you'll actually get the coordinate 18, 6. Because this has to go in alphabetical order. So the point of intersection for these is going to be 18, 6. Sometimes the equations will be backwards. You'll have an x equals a 3y or something like that, and you'll actually end up finding the y-coordinate first, and then you'll have to solve for the x-coordinate. Just remember to list them in alphabetical order, because that's how it also works in math. Alright, let's see. We have m equals 4n. Then we have 3m minus 2n equals 20. So in this particular system of equations, we have m equals 4n, and then 3m minus 2n equals 20. Well, we could take that m equals 4n and substitute that into the second equation. So it's going to look like 3 times your value of m, which was 4n. So you'll have 3 times 4n minus 2n equals 20. So 3 times 4n, that's 12n. You'll have 12n minus 2n equals 20. 12n minus 2n, that's 10n. That'll give you 10n equals 20, which means n has to equal 2. So your n coordinate of the point of intersection is 2. Now all you have to do to find your m coordinate is take that n coordinate of 2 and put it into one of these equations. I'm going to put it into m equals 4n. So m would equal 4 times 2, which means m equals 8. So the m coordinate for the point of intersection is 8. The n coordinate for the point of intersection is 2. So you'll get the coordinate, the ordered pair 8, 2. That would be your point of intersection, would be 8, 2. So yeah, substitution's really not that bad. Alright, let's see. We have s equals t plus 2. Then we have 2t plus s is equal to 17. Alright, so we have s equals t plus 2, then 2t plus s equals 17. So, we can still do a substitution here. It's just not as clean as it was before. In the second equation, we can take that t plus 2 for s and substitute that in. So what this is going to look like is you'll have 2t plus your s value, which was t plus 2. So you'll take 2t plus t plus 2 is equal to 17. Well, this would give you 3t plus 2 equals 17, which has to mean 3t equals 15, which means t equals 5. So we found the t coordinate for the point of intersection. That's going to be at 5. Now we want to find the s coordinate. To find the s coordinate, just pick your 5 and put it in for one of the two equations where you see t. I'm going to go with s equals t plus 2, so s would equal 5 plus 2, which means that s equals 7. So, in the end, you got your s coordinate 7, t coordinate 5, so these two lines intersect at 7, 5. That would be your answer for this system of equations, would be 7, 5. Alright, we got c equals 3d minus 4. Then we have c plus d equals 16. So this system of equations, you have c equals 3d minus 4, c plus d equals 16. Well, we can still do substitution, take that value for c, put it into the second equation, so that 3d minus 4 goes where c is in the second equation. So you'll take 3d minus 4 plus d, set that equal to 16, which this would give you 4d minus 4 equals 16, which would become 4d equals 20, which means d equals 5. So we have the D coordinate for the point of intersection being 5. Now we simply must find the C coordinate. This time I'm actually going to go with the second equation. We'll have C plus D equals 16, so we'll do C plus 5 equals 16, which would mean that C equals 11. So the C coordinate's 11, the D coordinate's 5. So the point of intersection of these two lines would be 11, 5. And that would be your answer for your ordered pair. You would get 11, 5. Substitution by far is my favorite method, to be honest, because it's usually the easiest. Alright, this one might not be as obvious here, but we have 3x plus 1 equals y. Then we have 2x plus 3y equals 25. So in this system of equations, we have 3x plus 1 equals y, and then 2x plus 3y equals 25. Well, we can still do substitution because you have something equal to y. So, though it's backwards, normally you'd see y equals 3x plus 1. It really doesn't matter. You can substitute that 3x plus 1 in for y in the second equation. So how that's going to work is you'll still have your 2x plus your 3 times your y value of 3x plus 1. You're going to set all that equal to 25. So let's do some distribution here. You'll still have 2x plus 3 times 3x, that's 9x, plus 3 times 1, that's plus 3. That equals 25. Which this will turn into 11x plus 3 equals 25, which means 11x equals 22, so then x has to equal 2. So the x coordinate for this system of equations is going to be 2. Now, of course, we want to solve for the y coordinate. And that might be easiest done, honestly, in the first equation where 3x plus 1 equals y. So y is going to equal 3 times that x value of 2 plus 1, which would equal 6 plus 1. So in the end, you get the y coordinate being 7. So the x coordinate is 2, the y coordinate is 7. Therefore, your point of intersection is the ordered pair 2, 7. That's going to be your answer for this equation, is going to be 2, 7. Alright, let's see. We got 3a equals 2b minus 6. And then we have a equals b minus 1. So this is a little bit different here. We have 3a equals 2b minus 6. Then we have a equals b minus 1. Well, we can still do substitution, but so far we're used to seeing your substitution expression being your first equation. This time it's your second equation, a equals b minus 1. You always want to get one of the variables by themselves on one side if you can. Whenever you see that, that could be your perfect substitution equation. So I could take that a equals b minus 1, I could put that into the first equation. So how that's going to work is I'll have 3 times b minus 1 equal to 2b minus 6. Well, let's do some distribution. You would get 3b minus 3 is equal to 2b minus 6. So let's get rid of the b from the right hand side, which means you got to subtract 2b from the left. You would end up getting b minus 3 equals negative 6. Then we want to get rid of that 3 on the left hand side, so you add 3 to both sides. You'll get b by itself is equal to negative 3. So the b coordinate of your point of intersection is negative 3. Now we just want to find the a coordinate. I think it's obvious. We want to put that b equaling negative 3 into the second equation. So we'll have a equals negative 3 minus 1, which means a equals negative 4. So your a coordinate is negative 4. So in the end, you get the ordered pair for your line of intersection being negative 4, negative 3. That would be your point of intersection, would be negative 4, negative 3. All right. Let's see, 4f minus 3h equals 0. Then f plus 4h equals 19. So we have this system of equations here where you have 4f minus 3h equals 0. Then you have f plus 4h equals 19. Well, it's not readily apparent which one is going to be your substitution. However, we do see we have an f with a coefficient of 1. If we could get that f by itself in the second equation, we could find the perfect substitution identity. So I'm going to draw an arrow here for the second equation. If I subtract 4h from both sides, I do get f by itself. F would end up equaling 19 minus 4h. So f equals 19 minus 4h in the second equation. I now have something I can work with for substitution. So what I can do now is take that f equals 19 minus 4h, put that into the first equation. So that's going to be 4 times 19 minus 4h, all that minus 3h equal to 0. Well, 4 times 19, that's going to be 76. Minus 4 times 4h, that'd be minus 16h. Minus 3h, that would equal 0. Oh well, I wrote in black, no big deal. So then we'll have, let's see, this would turn into 76 minus 19h would equal 0. Now we want to get that negative 19h by itself, so let's subtract 76 from both sides. You do that, you'll get negative 19h by itself. That'll equal negative 76, which means h in the end would end up equaling positive 4. So the h coordinate of the point of intersection is at 4. Now we just simply want to go through and find the f coordinate. And all we have to do is take this h coordinate, put it into one of these two equations. So I have f equals 19 minus 4h. Why don't we go for that? F equals 19 minus 4 times the value of h, which was 4. That equals 19 minus 16. That means f equals 3. So I have the f coordinate 3 and the h coordinate 4. So that means your point of intersection is the ordered pair 3, 4. And that would be your answer to this one, would be 3, 4. All right. We got 3n plus 5m equal to 7. Then we have m minus 4n equals 6. So in this particular system of equations, we have 3n plus 5m equals 7, m minus 4n equals 6. And at first we don't see an obvious substitution, but we do see an m with a coefficient of 1, so it looks like we could target that one and make that one our substitution equation. So notice that if we take m minus 4n and add 4n to that, we get the m by itself, but you got to add 4n to the right, you would get m equals 4n plus 6. Now we have it just perfect where we can substitute that m equals 4n plus 6 into the first equation. So let's go ahead and do that. You'll have your 3n plus your 5 times that value of m being 4n plus 6, all that equal to 7. So you still have 3n plus 5 times 4n is 20n, plus 5 times 6 is 30, all that equal to 7. So on the left hand side you would get 23n plus 30 equal to 7, which leaves 23n equal to negative 23, which means n equals negative 1. So we found the n coordinate of this being negative 1. Now we got to find the m coordinate, which all we have to do is put that into our substitution equation. That n value goes in the substitution equation, so you'll have m equals 4 times negative 1 plus 6, which means that's going to be equal to negative 4 plus 6, which means m equals positive 2. So in the end, you'll get the coordinate 2, negative 1 as your point of intersection of these two lines. So you would end up getting 2, negative 1. Alright, let's see. We have 2a minus b equals 17. Then we have 3a plus 4b equals negative 13. So in this system of equations, we have 2a minus b equals 17, then 3a plus 4b equals negative 13. Well, what we have here, we still want to do it by substitution. What I'm going to recommend is you get that you have a coefficient of negative 1 on the b, but it can become a positive coefficient of 1 if you move it over to the other side. So let's manipulate the first equation to make that our substitution equation. I'm going to do that over here. So 2a minus b equals 17. That means if I add b to both sides, I'll get 2a. that's going to be equal to b plus 17, which by the commutative property, not the commutative, by the property of equality, I can make b plus 17 equal to 2a. Now if I just want to get that b by itself, I just subtract 17. So I'll get b equals 2a minus 17. So this here will turn into b equals 2a minus 17. That would form a perfect substitution equation now. If you know how to manipulate and get certain variables by themselves, that's certainly an option. Then b equals 2a minus 17. Now, what I can do is take this equation here, substitute that in for where I see b in the second equation. So I'll have 3a plus 4 times that value of b, which is 2a minus 17. All that will be equal to negative 13. So then that gives me 3a plus 4 times 2a, which is 8a, minus 4 times 17, which would be 68. That would be minus 68 equal to negative 13. So 3a plus 8a is 11a. I end up having 11a minus 68 equals negative 13. And then I want to get the 11a by itself, so I add 68 to both sides. That would make it 11a equals 55, which means a can only equal 5. So my a coordinate for this line of intersection is 5. Now all I have to do is find the b coordinate, and I can substitute that value of a into that substitution equation. So b would equal 2 times that value of a, which is 5, minus 17, which means you have 10 minus 17. Therefore, b equals negative 7. So my b coordinate ends up being negative 7. So I get the point of intersection, the coordinate, the ordered pair being 5, negative 7. That would be my answer. Is 5, you get 5, negative 7 for your ordered pair. Alright, I think we'll do 2 more. I think we'll do 2 more for today, and then that'll do it. Alright, so what is the next one here? We have 2r plus 3s equal to 0. Then we have r plus 5 equal to 6s. So this particular system of equations, we have 2r plus 3s equals 0, and then r plus 5 equals 6s. Well, we see a coefficient of 1 on the r. We can pretty much make that our substitution equation. All we're going to have to do to get r by itself is subtract 5 from both sides. If you do that, you get r equals 6s minus 5. R equals 6s minus 5, that can become your substitution equation. So now you can take the substitution equation, put it into the first equation. So that's going to be 2 times that value of r being 6s minus 5 plus 3s, all that equal to 0. So 2 times 6s is 12s, minus 2 times 5, so that'd be minus 10, plus 3s equal to 0. So what you're going to end up getting is 15s minus 10 equals 0, which means 15s equals 10. Now if you divide both sides by 15, you'll get s, That's equal to 10/15, which they both have a common factor of 5, which would give you 2/3. So your S value for the point of intersection is 2/3. And yes, you can get fractional or decimal answers. That does sometimes happen. So don't be too alarmed by that. Now you want to find, so we got our S value, let's find our R value. Put that into your original equation of substitution. So you'll get R equals 6 times that 2/3 minus 5, which 6 times 2/3, so 6 divided by 3 is 2, 2 times 2 is 4. It's a call I could take in a minute. So we'll have 4 minus 5. That means your R value for the coordinate is going to be -1. So in the end, your point of intersection will give you the coordinate -1 2/3. So that will be your point of intersection, would be -1 2/3. Let's see, then we got, last problem, 3x plus 2y equals 11. Then we have x minus 2 equals -4y. So for this system of equations, we have 3x plus 2y equals 11, then x minus 2 equals -4y. Well, we want to do this by substitution method, so we got to find one of the variables to make a substitution for. I'm going to say that x has a coefficient of 1. That would be the perfect equation for a substitution. So in order to do that, to get x by itself, you just add 2 to both sides. You'll end up getting x equals -4y plus 2. So x equals -4y plus 2, there is your equation of substitution. Now you just need to put that into the first equation. So you'll take 3 times your value of x, which was -4y plus 2, plus your 2y, set that equal to 11. Do some distribution, you'll get -12y plus 6 plus 2y equals 11, which would just end up giving you -10y plus 6 equals 11, which means you would get -10y equals 5. So then you get y is equal to 5 divided by -10, that's -1/2. So you get the y coordinate of the point of intersection being -1/2. Now we just got to find the x coordinate, put that y value of -1/2 into your equation of substitution. Whoops, wrong color for this one. So let's see, we'll make x equal to -4 times our y coordinate of -1/2 plus 2. -4 times -1/2, that is +2 plus 2. Therefore, the x coordinate is 4. So, as the final result, the ordered pair for the point of intersection is going to be at 4, -1/2. And that would be your answer, would be 4, -1/2 to solve this system of equations. So that's it for the substitution method. The next lesson we're going to talk about the addition and subtraction method with systems of equations. So I hope everybody has a good day. Take care.